I want you to imagine that it's a beautiful Saturday morning, and you're driving to the airport to pick up a friend. The radio is on, maybe your favorite song is playing, and at first, everything seems natural. But then you hit the highway, and something feels off. You notice that the road is littered with debris, with abandoned, half-destroyed cars on the hard shoulder. You start swerving to avoid damaging your tires. Then suddenly, a red light blinks on your dashboard. You're low on fuel. Normally, you would stop at the next station, but for some reason, it's closed. You try to turn back, but the traffic is getting worse and you're blocked in. People in front of you are getting out of their cars, frustrated as the highway is becoming more and more unusable. With no one to help, no fuel, nothing to repair cars with, you start thinking, why did we even build this highway if we cannot maintain it? This seems like a fair observation, doesn't it? It is. It seems obvious to all of us sitting here that if we build a road, we shouldn't just put down concrete, but we should also build an infrastructure around it. And yet, that is not what's happening in space. And in space, the cars are not going at 130 kilometers per hour. The spacecraft are flying at 28,000 kilometers per hour. The nearest fuel station is not 50 kilometers away, but it's typically just non-existent. And if you need some help, no one is going to be there in 5 minutes. You will probably just get a bunch of engineers like me, sit down in a room with pen and paper, and figure out if they can actually help you, maybe in 5 years. In space, we have started using the orbital highways, but we have forgotten the maintenance crews. Today, I want to show you how and why that needs to change. When you think of space, maybe you think of an endless void. But around Earth, that couldn't be further from the truth. Space is incredibly busy. And if you have ever seen two cars collide on the highway at high speed, imagine what were to happen if that was at 8 kilometers per second. But let me actually show you. This is a picture taken by British astronaut Tim Peake. It's hard to see, but it's a window on the International Space Station. The 7mm damage that you see was caused by a paint flake or metal fragment at the size of a few thousandth of a millimeter. A few thousandth of a millimeter. That's roughly the size of a grain of sand, barely or not even visible to the naked eye. And that velocity, it can cause this damage to a window. So let's see what happens when we scale up. This is a 1 centimeter sphere. When it hits an aluminum plate at this velocity, it penetrates 13 centimeters deep. Just for reference, there are entire satellites less wide than 13 centimeters. So imagine if this is one of those. Or worse, the International Space Station with astronauts working on it. But you don't have to imagine this either. I'll show you. This is what happens when two satellites collide. And this is just an animation, but this is not fiction. This actually happened in 2009 between two satellites named Iridium and Cosmos. The result is total catastrophe. But the worst part isn't that we just lose two satellites that could be providing valuable data. After all, they could be weather satellites, right? But the worst part is on top of this, we also create 3,000 separate pieces of space debris that continue to orbit around Earth for a very long time. Imagine for a moment if this is how our roads worked. Imagine if every single time two cars collided, instead of taking those two cars out of the highway system, we would just add 3,000 cars back into it. Maybe you're trying to do the math now, but I've done it for you. Within 1 week, the roads would become 3 times as busy. Within a month, traffic would be 10 times as bad. But I think if we are honest, within a few days, none of us would be going to work anymore because the commute would be so unbearable. So let me show you how our scenic highways actually look at the moment. When humanity started its space journey, this is what we started from. Just a few lone satellites up in orbit. But since then, things have changed. Just in the last 5 to 10 years, we have launched more objects into space than the preceding 65 years alone. There are now over 140 million objects in space. Only everything that's bigger than 10 centimeters is shown on this graph. but 140 million. That's roughly the amount of kilometers between what we have between the Earth and the Sun. So how do you get around an incredibly busy highway like this? Well, on Earth, you could change lanes, you could go around the damage, and we can do this in space too. But in space, it has a cooler name. It's called a collision avoidance maneuver. But the numbers are starting to get concerning here as well. Just in the first half of 2025, SpaceX, Starlink constellation, has done 140,000 of these maneuvers. 140,000 is roughly one maneuver every 2 minutes. Just since the time you started listening to me, SpaceX would have done 3 maneuvers to avoid a collision just like the one I've shown you before. Would you go on the highway in these conditions? Would you let your loved one or a friend drive on the highway, knowing that if they just go for an hour drive, they will be exposed to 30 deathly accidents? I hope not. And I ask you this, if this is not acceptable on Earth, why should it be acceptable in space? So how do we make the danger more acceptable in space? How do we get these big, bulky tow trucks we have on Earth into a rocket ship and then send it off to space? And once they are up there, what do? I mean, tow trucks cannot work in space, right? We all know that. Well, you're partly right, but let's see a comparison. Space maintenance isn't as forgiving as Earth maintenance. On Earth, usually we are pretty prepared. If I have any sort of problem, we can pull up on the hard shoulder and we can call someone. They will usually come, do an inspection, and most issues they can repair on the spot. If they can't, they will call a tow truck, and that tow truck will take you wherever you need to go to repair the car. And of course, on top of this, there is a human on Earth who can call a fire engine, an ambulance, anything you may need that's based on the situation. But in space, things are not so simple. First of all, even finding the target is not so easy when the target is going at this 8 kilometers per second speed. Then once you finally find the target, you will have to do a visual inspection, because this is the first time you will see that object in space since it launched, probably many, many years ago. You will have to check for damage, but also for a safe feature you can actually dock to, which will usually be only one side of the spacecraft. And by the way, that frame video that you're seeing on the right, that is real footage taken in space. So if you think that I'm just saying fiction, this is real. Space maintenance is happening. So once you've done this visual inspection, we do something that I like to call a space dance. Because when you find this feature, you have to rotate with it as it's moving at this 8 kilometers per second speed. And of course, you have to do all of this automated. There's no human in space, so the spacecraft has to respond to anything that it needs to, that space can throw at it. And believe me, there's lots of things that space can throw at you. So, this doesn't seem so routine, right? It seems more like trying to change the tires of a Formula 1 car while it's running around the track, setting a personal best. Imagine for a moment if in Formula 1, the cars couldn't go to the pit stop, but the people in the pit stop would have to go around, race with the cars, and change the tires. That is how it's like to do maintenance in space. So who's doing all these crazy things? Who's doing the towing? Well, my favorite example is this lady. She's called Elsa. She's a mission I'm working on at my company Astroscale that plans to drive down a defunct satellite into a lower Earth orbit where it can release it safely. Elsa has a magnet that can attach to a docking plate and sensors to monitor the relative distance. All of these crazy space maneuvers you have just seen, Elsa can do it. And let me show you that whole process again so that you see how it all comes together. First of all, Elsa will drive up to the target at this 28,000 kilometers per hour speed. Then once it found the target, it will do the visual inspection, searching for that one area on the spacecraft that it can actually dock to. And I think now you can see why the space dance is a very fitting name. It's quite a complex and beautiful dance routine. And of course, after this, you need to lower the target and release it where it can safely burn up. And then Elsa can do all of this all over again. But Elsa is not alone. She has friends. This is Lexi. And unlike Elsa, who plans to bring satellites down, Lexi plans on keeping them up. Lexi will dock with another target and then provide power, communications, anything you may need in order to extend a satellite's working life. You can think of Lexi as a helpful little space mechanic. And of course, Lexi is also just part of a fleet. There are all these missions, Iris, Edrus, all these spacecraft, ready to become the next heroes of our space highways. Anything that we do for our cars on Earth, from damage diagnostics in your local garage, or refueling at a petrol station, or just changing the parts that need to be changed, these spacecraft can do it. And of course, they're just examples, but they're important examples of how we could turn space into the scenic highway that it's meant to be. If we don't, we might actually lock ourselves into Earth forever. And at this point, you may be thinking, okay, well, what has space ever done for me? Well, actually so much that today we're completely dependent on space. From emergency responders to food chain supplies, or even you, if you're checking Google Maps, if you're using GPS, you're using space. Can anyone tell me the weather outside? If you were going to look at your phone to answer that, you would be using space. And even if you just make a payment, or if you watch live sports, you're also using space. And none of this covers the future. From scientific discoveries to mining materials on the moon, finding a new base for humanity, all of these scientific discoveries are going to come from space as well. So it's truly a gold mine of opportunities. And next time someone comes to you with, why are we spending so much money on space research? I want you to challenge them and tell them all of these benefits that space provides. And I want to reiterate my earlier point. We don't accept this level of danger on Earth, so why should we expect it in space, accept it in space? Space isn't just out there. It's down here with us, and it's helping us keep safe and connected every single day. Remember that highway story in the beginning, with all the abandoned cars and the lack of fuel? We don't want that to become space. And I think we can all agree that a highway is not actually fit for purpose until we have the right infrastructure around it. So now, we've done pretty well on maintaining the highways on Earth, but it's time to maintain another one, but this time around Earth. It's time to actually take care of humanity's most essential highway. It's time to develop a road we can proudly call the Orbital Highway. Thank you.